Well, for this question, we have to draw the graph of a function that is continuous everywhere except at x equals -3. So let's draw a coordinate system. And here we are at -3. And so I'll just put an open circle there and connect it on either side with a smooth curve. And so there's the example of a function that is continuous everywhere except at x equals -3. And our task now is to find two one-sided limits. And the function we're interested in is f of t equals 1 over t to the 3/5 plus 7. And I've got the graph of the function here. And we've got a horizontal asymptote at 7, vertical asymptote at 0, and a t-intercept at -1 over 7 to the 5/3, 0. Now, using the graph, let's look at the limit as t goes to 0 from above of f of t. And as t approaches 0, the y value is approaching positive infinity. Now, let's do the other one-sided limit. As t approaches 0 from below, we'll follow the graph, and y is approaching negative infinity. So the limit is of the function as t approaches 0 from below is negative infinity. And we're done. Well, we have one final problem to resolve, and that is we have to graph y equals -3 over x minus 3. And we know by inspection that this has a vertical asymptote at 3 because the domain is all reals but 3. And if x were to equal 3, we'd have division by 0, which is undefined. So here we are at 3. X equals 3, and we'll draw this vertical asymptote. The horizontal asymptote is the x-axis, because since the numerator can never be 0, it's -3, then y can never be 0. So now, we know we've got one of two options. Either we're going to have, when we graph this, a hyperbola in these two quadrants, or a hyperbola in these two. So let's find that y-intercept, and that should indicate which quadrants we should draw our graph in. So let's look at, or I'll say this, if x equals 0, then y equals -3 over 0 minus 3, which equals -3 over -3, which is 1. So here we are at 0, 1, and now we know our graph looks like this. And like this. But just to verify that this is where we belong, let's look at, let's evaluate another value for x that's to the right of 3. So if x equals 6, then y equals, let's see, negative 3 over 6 minus 3, which equals negative 3 over 3, which equals negative 1. So if we go out here to 6, our ordered pair relative to this point is 6, negative 1. And it checks out. So we've graphed it. We've graphed this equation correctly. And we're done.